Alrighty, here we go, installment number 57, wow, of your MLOs for Math 2201. So we're going to start with just a couple of questions is all we're going to do here actually, about the graph of y equals ax squared for changing values of a and the effects on the properties of the parabola. Okay, so here's the first one. It says the graphs of y equals x squared. Okay, I guess that's the black one on top there, and y equals ax squared will be the red one on the bottom. They're shown. Which equation shows the correct value of a? Okay, so basically we have to determine what value of a would take the graph of y equals x squared up top and turn it into this one. That's the question. So what's the right transformation here? Well, let's talk about what happens to the graph first of all. The first thing we notice is that it's upside down. So we say that it's got a reflection over the x-axis. Sometimes you say in the x-axis, but the same idea. So it's been reflected over the x-axis. What else have we got? Well, they look very similar, except I think you'll notice that the red one down here is kind of squashed together a bit. It's sort of taller and narrower. So let's see if we remember. Taller and narrower. What does that mean for the value of a? All right. Alrighty. So if it's been reflected, what does that tell us about the value of a? Well, upside down, you should remember, it has to be a negative. And if it's taller and narrower, that means the absolute value, or forgetting about the negative for a second, we'd have to have a number that's bigger than 1. So a has to be a negative, and it's got to be a number that's bigger than 1. So let's look at our options they gave us. We've got -3, -1/3, +1/3, and +3. These two are out because we know we have to have positive. And the only one that's bigger than 1 there, between 1/3 and 3, is going to be just the 3. So a has to equal -3. That looks about right to me. Okay, good question. Determine the equation for the function graphed. Okay, so it looks like a parabola. Remember, all of our parabolas were transformations of y equals x squared. And the only thing we've really seen done to them so far is we've taken a times x squared. So the question here is, what's a? Alrighty, so let's think about what happens. Look at all the numbers. They very specifically gave us a bunch of numbers here. Well, they're all positive values for y. There's no reflection going on, so I know that a has to be a positive number. All right, and let's see. When we wrote out our original table of values, if you remember, all the y values were what we got if we took the x values and we squared them. So let's take a look at a few of these. Let's take just the -2, -1, 0, 1, and 2. So if we were just squaring those, and we were thinking about just y equals x squared, well, we'd have a 4, a 1, a 0, a 1, and a 4 if we squared them all. So let's look at the points on the graph and see how well they line up. So at -1, we're not at +1, we're at +3. So these 2 points were 3 times as big as we expected to be. And at -2, we're not at +4, we're all the way up at +12 on the graph. But again, that's 3 times as big as we expected to be. It looks to me like to get the y coordinates, we're multiplying what we expected to get by 3. So I'm going to say y equals 3 times x squared. Looks pretty darn tootin' good. Okay, so remember the things you got to keep in mind for our vertical stretch factor a. If it's bigger than 1, we're taller and narrower. If it's less than 1, we're shorter and wider. If it's positive, it opens upward. Negative opens up or opens downward, sorry, and it has no effect on the axis of symmetry or the coordinates of the vertex. See you next time.